In this section, we're going to be talking about 7.4, which is called double angle, and half angle identities. Now, we are going to be using the angles that we talked about in the beginning of the previous section, which we use the angles from our special triangles, 30, 45, and 60 degrees. We also use quadrantal angles, and then we could add these to 90 to give us additional angles to use. So what I wanted to do first is talk about double angles. So let's say if we wanted to figure out the cosine of 60, what we could do is we could actually use 30 to figure that out. We'll see some other examples later on of when it's necessary to use a double angle formula. But let me show you what these formulas are first. The sine of a double angle, 2 times an angle, is equal to 2 times the sine of A times the cosine of A. The cosine of a double angle is equal to the cosine squared of A minus the sine squared of A. Now from here we could actually use the Pythagorean identity that sine squared plus cosine squared is 1. And instead of cosine squared, we could replace it with 1 minus sine squared. And if we do that, 1 minus sine squared would be 1 minus 2 sine squared of A. Similarly, we could replace, we could bring the cosine squared on the other side, and sine squared would equal 1 minus cosine squared. So you would have cosine squared of A minus this is what I'm talking about here, cosine squared of A minus the quantity 1 minus cosine squared of A, which would give us our third formula, which would be cosine squared of A minus 1 plus cosine squared of A, which would be 2 cosine squared of A minus 1. So we actually have 3 formulas for the cosine of a double angle, and then the tangent of a double angle would be the formula 2 times the tangent of A divided by 1 minus tangent squared of A. So let's take a look at some examples. What if I asked you to find the value of sine and cosine for each angle, or let's say for the following. So our first example, I'm going to ask you to find the sine and cosine of 2 theta, so a double angle, given cosine of theta is negative 12 over 13, sine is positive, all right, and that's what I want us to find. So if sine is positive, let's think about why they told us that. What quadrants would sine be positive in if all students take calculus? The first and the second. So sine is greater than 0 tells us we're going to be drawing theta in the first or the second quadrant. But because cosine of theta is negative, we have to draw theta in the second quadrant. In quadrant 2, cosine would be negative and sine would be positive. Now cosine of theta is negative 12 over 13. So we'll label our triangle. And using Pythagorean theorem, let's go ahead and find the opposite side. So negative 12 squared plus y squared equals 13 squared. This is a special triangle, but in case you don't recognize it, we'll figure it out together. Y squared would be 25, so y is 5. We're going up, so it's positive, and as you notice, 12 is going left, so that's negative. Our hypotenuse is always positive. Okay, so we have our triangle, everything's drawn out, so let's go ahead and figure this out here. The sine of 2 theta, according to our formula, is 2 times the sine of theta times the cosine of theta. So 2 times the sine of theta, look at your triangle, sine of theta is 5 over 13, times the cosine of theta. We're told that, and our triangle shows us that it's negative 12 over 13. So if we were to type this into a calculator, we would get negative 120 over 169. Let's find the cosine of 2 theta. We have 3 formulas to choose from. It doesn't matter which one you pick. I'll just use the first one. Cosine squared of theta minus the sine squared of theta. Okay, well the cosine is given, and we could just look at our triangle. It's negative 12 over 13 squared minus the sine of theta, which is 5 over 13 squared. If you type that into your calculator, you would get 119 over 169. So that's how we could use the double angle formulas to answer an example like that. Let's try one more, and then we'll get to talking about half angles. I would like you to find, remember what the directions were. It says find the sine and cosine of, second example is just going to be theta. So find the sine of theta and cosine of theta given the cosine of 2 theta is equal to 3/4, and theta is in quadrant 3. Okay, so let's set things up. We're in quadrant 3. So we know that much. And we know that the cosine of 2 theta is 3/4. So the formula for cosine of theta, or cosine of 2 theta, is cosine squared of theta minus sine squared of theta is equal to 3/4. But that formula, we can't really solve for theta because we don't know cosine, we don't know sine. But let's use another formula. What if we could pick any of the other two? Let's use 2 times the cosine squared of theta minus 1 and set that equal to 3/4. Well, if we add 1 to both sides, we get 7/4. 3/4 plus 4/4 is 7/4. Divide by 2, or multiply by 1/2, you get the cosine squared of theta is equal to 7 over 8. You could take the square root of both sides, absolute value of cosine. Remember, anytime you take the square root of something squared, its absolute value is equal to the square root of 7 over the square root of 8. Now the square root of 8 we're going to have to reduce. I'll just do that off on the side here. Square root of 8 is just the square root of 4 times the square root of 2. So it reduces to 2 root 2. Rationalized would tell us that the cosine of theta is equal to the square root of 14 over 2 times the square root of 4, or 2 times 2. And this would be plus or minus. So we used the double angle formula to figure that out. We could have also used 1 minus 2 sine squared of theta and that would have given us the same answer, or it would have helped us get our triangle. Now, if we're in quadrant 3, and if all students take calculus, quadrant 3 uses a negative cosine. So in quadrant 3, cosine would be negative root 14 over 4. So let's go ahead and figure out the opposite side so we could determine what sine of theta is. So if negative root 14 squared plus y squared is equal to 4 squared, we get 14 plus y squared is equal to 16. Y squared would be 2. Y would be plus or minus root 2. Because we're going down, we're going to use negative root 2. So what would the sine of theta be? Sine of theta would be negative root 2 over 4. That's how we solve a problem like that. Now let's work on the half angle identities. And the half angle identities say that the sine of any angle divided by 2 is equal to plus or minus. We have to determine that based on all students take calculus of 1 minus the cosine of A divided by 2. The cosine of a half angle is equal to plus or minus the square root of 1 plus the cosine of A over 2, and the tangent of A over 2 is equal to plus or minus the square root of 1 minus the cosine of A over 1 plus the cosine of A. So those are our half angle identities. I'm just going to clean this up a little bit. I'll draw some smaller radicals so it looks nice and pretty. And now let's take some examples with those formulas. Let's use a half angle identity to find the exact value of so our first example, let's find the exact value of the sine of 165 degrees. Okay, well, in order to use a half angle, we have to determine what angle we could divide by 2 and get 165. So 165 times 2 is 330 degrees. And now let's set up our formula. The formula is plus or minus the square root of 1 minus the cosine of that bigger angle divided by 2. Now the question is, are we going to be using the positive or the negative? Well, that comes from this angle. So the question is sine of 165 positive or negative? Well, 165 is in the second quadrant, and we're looking to find the sine. So sine would be positive there. You don't use 330 to figure out what the sine is. You use the original angle. 165 is positive. If you were to type sine of 165 into your calculator, you would get a positive answer. So now let's figure out what the exact value would be. I'll draw 330 to do that. 330 puts us over here in our fourth quadrant. and that gives us a reference angle of 30 degrees. So I'm going to draw our sides, 1, 2, and root 3. Anytime you go left or down, that's a negative side. And let's fill in for our formula. We're going to have the positive square root of 1 minus the cosine here, which is root 3 over 2. And we're going to be dividing by 2. Now you could see we have a square root inside of a square root, and then fractions, it's a mess. What we could do to get rid of this fraction right here is multiply the top and bottom by 2. That would get rid of our fraction, and that would actually make our denominator the square root of 4, which would take care of the square root. So this will be this large square root. On top, it's going to be 2 minus root 3, because the dividing by 2 canceled. On the bottom, it's going to be 4. And the best answer for this, if you take the square root of the top, 2 minus the square root of 3, over the square root of 4. That is our best answer. Now the top is interesting, right? Because you have a double square root. That's okay. You're just not allowed to have a square root in the denominator. Let's try something else. How about the tangent of 67.5 degrees? Well, 67.5 times 2 is 135. That's the angle. If we divide by 2, we'll get 67.5. Let's figure out if this is going to be a positive or negative. And that's going to come from 67.5. That's in quadrant 1. So in quadrant 1, all of angles are positive. So we're going to be using the positive sign. And now let's draw 135. 135 puts us in the second quadrant with a reference angle of 45. So we have 1, 1, and root 2. Anytime you go left or down, it's negative. So let's do this. Our formula says we're going to be doing 1 minus the cosine of 135 over 1 plus the cosine of 135. So this turns into the positive square root of 1 minus the cosine. Now the cosine would be negative 1 over root 2. But we know eventually we're going to have to rationalize. So let's just do it here before we go putting it into our formula. So the cosine of 135 would be negative root 2 over 2. Over 1 plus the cosine of 135. We have another fraction on top and bottom. So I'm going to multiply top and bottom by 2 over 2. That'll take care of our fraction, and then we'll see what we're left with to clean up. We're going to have the square root on top of 2 plus root 2 over the denominator, which is going to be 2 minus root 2. So inside of our radical, we still have radical in the denominator. So let's get rid of that. We'll multiply by the conjugate of the denominator, 2 plus root 2 over 2 plus root 2 while we're still inside the radical. On top, we're going to have 4 plus 2 root 2 plus 2 root 2 plus the square root of 4. And in the denominator, we're going to have 4 plus 2 root 2 minus 2 root 2 minus the square root of 4. All right, let's start cleaning it up a little bit. On top, we're going to have 4 plus the square root of 4. So I'll combine these two terms. 4 plus the square root of 4 is 6 plus 4 root 2. That's our numerator. And in the denominator, we're going to, these cancel. 4 minus the square root of 4, or 4 minus 2, is just 2. All inside of big radical. Now what we could do is we could divide everything on top by 2, right? So we'll do 6 over 2 is 3. 4 root 2 over 2 is 2 root 2. That's inside of the square root. We have no denominator now because we simplified, and that would be our final answer. Took some work to get there, but the trigonometry part is easy, right? I mean, the cosine of 135, the positive or negative, that part's easy. This right over here is kind of a test of how strong your algebra skills are, but it's not anything super heavy duty, so I'm confident you could do this. Let's move on to our last example for this section. Let's say given cotangent of x is equal to -3, and x is between pi over 2 and pi, find the cosine of x over 2. All right, so we see a few different things here. We have x, so that means radians. And if x is between pi over 2, well, that was 90 degrees. Pi is 180 degrees. So let's go ahead and draw our triangle between 90 and 180. That's quadrant 2. That's between pi over 2 and pi. So this tells us we're in quadrant 2. The cotangent of x is -3. Remember, cotangent is the reciprocal of tangent. So if cotangent's -3, tangent would be -1 over 3. And anytime you go left, it's negative. Okay, so now let's find the hypotenuse. -3 squared plus 1 squared is our hypotenuse squared. 9 plus 1 is 10. So your hypotenuse is the square root of 10. Now that we have our full triangle, let's go ahead and see if we can answer this question. Find the cosine of x over 2. Okay, so the cosine of x over 2 is going to equal positive or negative square root of 1 plus cosine of x all divided by 2. Okay, well, if x is in quadrant 2, where would x over 2 be? That's what we're asked to find. We're asked to find the cosine of x over 2. So let's pick an angle in quadrant 2. Maybe use 100 degrees. What would x over 2 be? 50 degrees, right? So this is really telling us this is going to be in quadrant 1. Let's pick another angle in quadrant 2. How about 179 degrees? That's the largest, almost the largest angle in quadrant 2, right? We could really use 179.9 if you wanted. Well, what's 179 divided by 2? 89.5. So no matter what angle x is, as long as it's in quadrant 2, when you divide it by 2, you wind up with an angle in quadrant 1. So we have to choose the positive answer for this. So let's keep going here. It's going to be the positive square root of 1 plus the cosine of x. Okay, so 1 plus the cosine of x. I'll do that over here because we are going to have to rationalize. The cosine of x would equal -3 over the square root of 10. Let's multiply top and bottom by the square root of 10 over the square root of 10. And going inside of our radical, we'd put -3 root 10 over 10. And the whole thing is being divided by 2. So let's get rid of radicals, and then we'll see what we need to do to simplify this. I'm going to multiply the top and bottom by 10. And we get 10 minus, the 10 on top here would cancel with this. So you just have 10 minus 3 square root of 10 over 2 times 10 is 20. Okay. Now, let's see here. We want to be able to get rid of this square root of 20 on the bottom, right? If we were to break up this radical, we would have to take the square root of 20, or the square root of the top over the square root of the bottom. So if we multiply the top and bottom by 5 over 5, we'll get a perfect square root in the bottom. This will tell us we'll have the square root of 50 minus 15 root 10 all over the square root of 100. So as far as what our final answer would be, it would be the square root of 50 minus 15 root 10 all over 10. That's as simple as we could make our answer. All right, so thank you for your attention with this. So please stay tuned for our next section.